Okay, so today I want to look at the theorem of Pythagoras. Theorem of Pythagoras. All right, so I did write some sticky notes there. I'll start with the one that is in red. All right, so this one states that a right-angled triangle is a triangle that contains a right angle. Okay, a right-angled triangle. A right-angled triangle is a triangle that contains a right-angled triangle. Okay, I need to repeat this because the theorem of Pythagoras only applies to a right-angled triangle. I will repeat. The theorem of Pythagoras only applies to a right-angled triangle. And what is a right-angled triangle? A right-angled triangle is a triangle that contains a right angle. What is a right angle? You can see here. This is a right angle. This is a right angle. So before you even think of applying the Pythagoras theorem, first identify whether the triangle is a right-angled triangle. That is the first thing that you should take note of. Okay, then the second thing that you need to take note of is the point that I wrote in green, that the side opposite the right angle is called the hypotenuse. All right, the side that is opposite to the right angle. So you can see here that this is the right angle in red. This is the right angle in red there. So that angle there is the right angle. Okay? And the side that is opposite to that right angle is what we call the hypotenuse. So if I'm to um, use my green pen here, you can actually see that the angle that is opposite to this right angle happens to be this side here. Okay? That's the side that is opposite to the right angle. So the side that is opposite to the right angle is the side that we call the hypotenuse. That's the side that we call the hypotenuse. Hypotenuse. So that's how you are able to identify this the side which is the hypotenuse. Okay, the hypotenuse is always the side that is opposite to the right angle. Okay, that's the hypotenuse. And what is this hypotenuse? Now we are going on to the next um, point that I wrote there, that this right angle, this hypotenuse, is the longest side of a right-angled triangle. So if you are to check and compare between the sides, the side AC and side AB, let's see which side is the longest here. If you are to check, you can actually see that side CB is the longest side. Side CB is the longest side. So that's another way you can use to identify the hypotenuse by just looking at which side is the longest side. All right. So these are the 3 points that you need to consider for you to be able to apply the theorem of Pythagoras. So what is the theorem of Pythagoras? What does it state? Okay, so the theorem of Pythagoras states that um, the square of the hypotenuse, okay, let me draw the right angled triangle one more time. So this is a right angled triangle. Okay. So it's supposed to be straight there, but did my best. All right. So this is a right angled triangle, as you can see. So let's just call it ABC, triangle AB, A, B, and C. Okay. Then I'm going to name this side C here, this side B because it's opposite to the angle B. And then this side I'm going to name it A because it is opposite to the right angle A. All right. So now I want you to pay attention to what I'm going to say here. So I'm saying the theorem of Pythagoras, it states, let me write it here. What it states. All right. So the theorem of Pythagoras, it states that, all right, I want to write it here so that you know. All right. So the theorem, I'm going to type it, the theorem of Pythagoras states that the square, of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, that's what it states. That's what it states. Okay, that's what it states. So Pythagoras theorem states that it states that the square of the hypotenuse is equal. All right, let me write equal nicely there. Is equal to the sum of the squares of the other two sides. All right, let me write a nice spelling for square there. All right, that's better. Okay, so the theorem of Pythagoras states that the square of the hypotenuse. So what is my hypotenuse? So what we did discuss just now is that the hypotenuse is opposite. The hypotenuse is opposite to the right angle. So this is our right angle. So which side is opposite to the right angle? It's A. So that makes A our hypotenuse, okay? That makes A our hypotenuse. So the first thing you do is to identify your hypotenuse. So the theorem of Pythagoras states that the square of the hypotenuse, which happens to be A squared, all right, that's the square of the hypotenuse. So A is our hypotenuse, right? So I'm going to say A squared here. That's how I'm going to write it. So the theorem of Pythagoras states that the square of the hypotenuse, A squared, right, is equal to the sum of the squares of the two other sides or of the other two sides. All right, what are the two other sides? The two other sides is B and C. So A squared is equal to the sum of the squares. So A squared is equal to B squared plus C squared. All right. Okay, so this is what Pythagoras theorem states. that the square of the hypotenuse is equal to the sum of the squares of the other two sides. That's what Pythagoras means. So a squared is equal to b squared plus c squared. All right. So this is Pythagoras theorem. This is what Pythagoras theorem state. All right. So now that I found the theorem of Pythagoras, if let's say I want to find the side C, okay, what I just need to do is to use this Pythagoras theorem to find any missing side. Whether I'm finding the hypotenuse or I'm finding the other two sides, I use this Pythagoras theorem. So let's say in this case, I want to find side B. Okay, I want to find side B. I want to find side B, which I am circling right now. That's side B. So what I simply do is I rearrange. I re I rearrange, okay? I rearrange. So that means um I'm going to write, okay, let me just write it down one more time. A squared is equal to B squared plus C squared. Okay, so I want to find the side B squared. So that's the side B, which is the B squared here. So what do? I rearrange and make B squared the subject of formula. So what I'm going to do, I'm going to take this C squared to the other side. Yeah, I'm going to take C squared to the other side so that on the left side, I will remain with A squared minus C squared is equal to B squared. Okay, so this becomes the formula to find side B squared. Okay, what if I wanted to find side C here? Simple. I take the standard form of Pythagoras theorem, which is hypotenuse squared is equal to B squared or side squared plus another side squared. Then I make the side that I'm trying to find the subject of formula, which happens to be C, right? So what I do is I take this B squared to the other side, all right? So that on the left side, I will have A squared minus B squared is equal to C squared. So this becomes the formula that I will then use to find my C. All right, so let's get into a practical example that we can apply. All right, so I'm going to draw a right angle triangle. Okay, so let's assume this side here is 3 and this side here is 4. Okay, then they want me to find side, let me just say side X. That's the side that I need to find. So first things first, I'll need to identify my hypotenuse. I need to identify my hypotenuse. So what I do is I first locate my right angle and the side that is opposite to that right angle will happen to be my hypotenuse. So you can see that X is my hypotenuse, right? My hypotenuse. Okay, so after identifying my hypotenuse, I will then know that the theorem of Pythagoras states that hypotenuse squared, which is x squared, is equal to these two sides squared added together, all right? Which is 3 squared plus 4 squared, like this. All right, then x squared is equal to 9 all right, plus 16. All right. Then I'm gonna add 9 plus 16, which gives me 25, right? Yeah. So x squared is equal to 25. All right. Am I done? Nope, I'm not done. Remember, I'm solving for the x now. It's more like an equation. So I can't leave that squared on that x. I need to get rid of the squared by square rooting both sides. I square root the left side, then I square root the right side. Therefore, x is going to be equal to 5. So therefore, I have managed to find the missing side, x, which was my hypotenuse. So I know that this side is equal to 5. All right. So let's assume we were asked to find this side here. Okay. So I'm going to draw the same right angle triangle. I'm going to draw the same right angle triangle. So let's say our hypotenuse is 5 and this side is 4. And the side that I need to find is this side x. Okay, so I already know that this 5 here is my hypotenuse. That's my hypotenuse because it is opposite to this right angled triangle. Okay, so this happens to be my hypotenuse. So I then apply the theorem of Pythagoras, which states that the hypotenuse squared, all right, which is 5 squared, is equal to the two other sides squared added together, which is going to be x squared plus 4 squared, right? So 5 squared is 25, and then this is x squared. 4 squared is 16, and this is going to be 16. So what am I going to do next? I'm now solving for x, so I need to take this 16 to the other side, where it's going to be subtracted. And then this side here, x squared. All right. Then now I subtract 25 minus 16, I get 9. So 9 is equal to x squared. Then what's next? I'm going to square root this side. Then I'm going to square root the other side. It's okay. So you can see that 3 is equal to x. Wow. You see, we still got the 3. Here, this 3 here, we still got the 3. Okay, let's find this side then. Let's assume they'd given us this side here and our hypotenuse here, and they wanted us to find this side here. Okay, so I'm going to draw the right angle triangle one more time. Want to see if we apply the theorem of Pythagoras, if we are going to get 4. All right, so our hypotenuse is 5, right? And then this side is 3. So let's say this is the side that we want to find. So I'm going to call it x. All right, so I'm going to apply Pythagoras theorem. Then we'll see whether we're going to get 4. Okay, so first identify hypotenuse. So like we said, this is our hypotenuse. All right, then what's next? I'm going to apply Pythagoras theorem, which states that the hypotenuse squared is equal to um, these two other sides squared added together like this. 3 squared plus x squared. Okay, 5 squared is 25 is equal to 3 squared is 9, then plus x squared. So what am I going to do next? I'm going to take this 9 to the other side, where it's going to be subtracted. So now I have 25 minus 9 is equal to x squared. Okay, then 25 minus 9, I get 16. So 16 is equal to x squared. Okay, then I square root this side, and I square root that side. So what is the square root of 16? Is 4. So 4 is equal to x. You see? I still got 4 here, right? Which is the 4 that is here. Okay, so Pythagoras theorem works. Pythagoras theorem works. So the theorem of Pythagoras states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So that is Pythagoras theorem. Find one or two questions and try to apply the theorem of Pythagoras and see if you're gonna get the answers right. Cheers. Bye-bye.